Basic kinematic quantities, right? There is angular displacement, right? So here is, we could say clockwise pi over 2, right? We could make that positive or something like that, right? Here is anti-clockwise pi over 2, right? And you know, obviously it can be more than 2 pi, right? Okay. And then there's angular velocity, right? We could say clockwise, right? We could somehow make that positive, and that's a positive angular velocity. And then there's maybe this is anti-clockwise is negative, right? And then I introduced the concept of, for velocity, that we represent velocity as with the right-hand rule, right? So if we put our fingers in the direction of the spinning, right? And if we do that, we'll get an angular velocity vector that you can represent as an arrow, right? That's the direction of the angular velocity, the direction of the angular momentum, like that. And they think that's bizarre, but it really does make sense later on. And then, you know, for angular acceleration, I always like to bring up Ezekiel's wheel, right? This cool thing, right? So I put this on there and you can see it accelerating, right? And you know, they haven't, at the point when we're doing this, they haven't really talked about a moment of inertia or anything like that. But I do ask them and say, look, if we move these out to the outside, is it going to accelerate faster or slower? Just to give them sort of a foreshadowing or something like that.